Hello everyone, I am Abdul Kadir and I am going to talk on our research on the overlap between Grad-CAM saliency maps and explainable visual features in skin cancer images. My colleague Dr. Fabrizio Nunnari and Dr. Daniel Sonntag and I work together in German Research Center for Artificial Intelligence, and Dr. Daniel Sonntag is also a professor in Oldenburg University. Before starting the presentation, I would like to give you a little bit of context and motivation. We were motivated by Isaac competition in skin lesion analysis, and Isaac competition gives us the data for this competition. And there were three tasks in Isaac 2018 competition. Basically, we were focusing on Isaac 2018 competition uh, for this research. And in this research, there were three tasks, as I said before, and they are lesion segmentation, attribute detection, and disease classification. In this work, we extensively focus on attribute detection, and we try to find out to what extent visual features or so-called attribute can be generated from a CNN classifier. Now I'll give you a hint on the related work that we looked around before our starting our research, and mainly the competition has a lot of related works because there were a lot of organization involved in this competition, and there were research outcome on those areas in attribute detection. And on that competition, there were 2,594 images were given for attribute detection, and separated people use separated model for attribute detection. For example, some people used CNN classifiers and so on. So there are other researches on skin cancer detection. For example, Inception 3, version 3 were used for skin cancer detection, which is also similar to our task, but they were more on image classification and or cancer detection. And these researchers came out with very good result. However, this research doesn't explain why this kind of classification happens. What is the explanation behind the classification? And also, there are more research on explaining the classification, and this research involved ResNet 50 architecture and VGG 16 architecture also. And the researchers used Grad-CAM, Grad-CAM++, RISE or LIME to explain the explanation. However, there are limited standard for evaluation criteria. For example, whether the saliency map is correct or not, it is very hard to understand by comparing with the ground truth attribute. For example, saliency map is not always equal to the attribute, because attribute is more like a binary mask, whereas saliency map is a full image with highlights in several regions. So some people did that they convert this saliency map with a threshold value, with a threshold value, and made a binary mask, and they compare it with the ground truth. However, during this threshold value they choose 0 0.5, but what is the best approximation? It's an assumption that we use 0 0.5, but why 0 0.5 is a good value to detect, to convert by convert a convert a saliency map to a binary image. It's a it's a topic of research from our point of view. So we decided that okay, we look around like what threshold value can maximize the overlap between saliency map and ground truth. In our approach, we first trained a classification model using the classification data from Isaac competition. Then we generated saliency map using the same model, and we used Grad-CAM for that. And then we convert this saliency map to binary attribute map, and we proposed a way to find a threshold value for accurate conversion. We tried from zero point 0.0 threshold value to maximum 1, and then we compared two different networks, for example VGG16 and ResNet 50, to check the significance of the size of the saliency map on the attribute detection. The two architectures have a different classification accuracy. Here we give explanation on the accuracy, and we see that the overall accuracy of VGG16 is 0.72 and ResNet 50 is 0.76. We see ResNet 50 performs well in classification compared to VGG16. Now I am going to talk on the dataset. We used ISAC 2019 task 1 data for training the original classification models. ISAC 2018 data doesn't have any overlap with ISAC 2019 data. So for this task, we used ISAC 2018 task 2 attribute detection data, and there are several attributes like globules, tracks, milial cyst, negative network, pigment network. Here is an example. For example, this is the image, and this is like the segmentation, and this is the globules, and this is pigment network, and this is tracks, and this is the union of all the attributes. So in this data in ISAC 2018 class, task 2 attribute data, there are 519 melanoma images and 1869 nevus images. So there are not many classes available, only two classes available, but as we trained on the whole classes, so it's like a whole 8 classes, so it's not a problem for us because we can classify these images fairly well from those models. Now I would like to show you the saliency map generated from two models, and we used Grad-CAM as I said before. So from these two models, for example VG16 and ResNet 50, we get this kind of saliency map for input image, this one. So in this saliency map, we see that VG16 provide us a bigger saliency region compared to the ResNet 50, and then we do convert it in the grayscale, and then we convert with different threshold values. For example, we use several threshold values. For example, with 0.0, we get a completely white mask. On the other hand, with a larger threshold value, we get the following binary map from the saliency map. So here is the VG16 and here is the ResNet, and we see this as binary images that gives the information on the saliency map. And we used a Jacquard index to find out find out the similarity between the attribute and the saliency map for each of the cases from 0.1, 0.0 to 1.0. So Jacquard index increases or decreases based on the threshold value. We found that we can choose a threshold value that increase the overlap between the saliency map and ground truth attribute. So here is the summary of the different threshold value and its significance. For example, each of the attributes, there are different threshold values, and here we see that VGG16 and VG ResNet 50, and the ResNet 50 has a better average Jacquard index compared to VGG16, and yeah, but we have to keep in mind that it's not about only the overlap maximized or not, because we have to find out that whether it's came by accident or not by finding out the statistical significance of those values. So Jacquard index, based on classification, we found out that for a correct melanoma class, there is a best threshold value is 0.5 and Jacquard index is 0.15135 in VGG, And for wrong classification, the melanoma wrong is for melanoma wrong classification, the Jacquard index is very low, 0.086. And for on the other hand, for ResNet 50, the Jacquard index doesn't very much. They are very close for wrong and correctly classification. So we tried out that why this kind of result came, because we don't find a really big difference in the wrong classification and correct classification on different classes. So what we only see that for melanoma correct and melanoma wrong, and the Jacquard mean value varies significantly, and for the other cases, and the Jacquard index value is relatively closer to each other. So we can summarize that VGG16 gives Jacquard indexes which differ significantly between correct and incorrect classifications. To understand whether this Jacquard index and those threshold values came due to an accident, we tried to do a significance test, and we did a Mann-Whitney U test between Jacquard indexes of correctly and wrongly classified classes. For example, for model VGG16 and VGG and ResNet 50, we see that we compared the result of melanoma correct and melanoma wrong, and we find that the p-value is 1.2 into e to the power minus 7. And for nevus, we also find the result correct and wrong classes. The result Jacquard index is also significant because the p-value is also less than 0.05. On the other hand, for ResNet 50, the p-value is higher, 0.86, and for nevus it's 0.39. So this is the point where we see that well, the ResNet gives a good overlap between the saliency map, but they are not really meaningful after finding out such a big p-value. So from this, we can conclude that from VG16, we see that the different Jacquard index for wrong and correct classification are statistically significant. On the other hand, for ResNet 50, the result came due to randomness. So this is the point that even though ResNet 50 performs well in the classification and also gives better overlap with with the attribute, but these are due to the randomness. And so at the end, I would like to say that the threshold value is is a hyperparameter because we can choose threshold value for different tasks, and they are this threshold value affects this the overlap. For example, a good threshold value can increase the overlap, and it's a misleading. It is misleading to use zero point 0.5 in every experiment. And also, we'd like to say that in VGG16, high resolution saliency for wrongly classified melanoma, the saliency deviates significantly from the ground truth. So this can suggest doctors that machine is taking a wrong decision. And deeper network can produce good classification accuracy, but explaining result, they are less useful than shallower network. For example, ResNet 50 is a very deep network, but it cannot produce good saliency compared to the VGG16, which is a bit shallower than ResNet 50. Thank you all, and please feel free to ask any question.